In this section, we are going to talk about what a function is, and we are going to do various things with functions throughout the course of the chapter. First, we need to actually define what a function is. Okay? So a function, denoted by f of x, is a rule that defines for all values x in a set A, which we're going to call the domain, a specific value f of x in a set B, which we're going to call the range. Another way to think of this is a function is the set of all ordered pairs x comma f of x, where x is in A and f of x is in B. And we can define the domain and range specifically as the domain is the set of all x, where x is in the one set, and the range, where f of x, the set of all f of x, such that x is in that set. Okay? So those are our domain values and our range values. For some of the functions that we're going to look at, you're going to be asked to find both the domain and the range. Other functions, you're only going to be asked to find the domain. As we start out, you're just going to be looking at domains of functions because the ranges for these take a little bit more to actually figure out what they are. Okay? So here's a couple of examples of domain. And again, if we think about domain, for us, we're going to be looking at real valued functions. So domain to us means the real numbers that we can put into the function that give us real numbers out. So looking at these examples, this first one, g of x equaling 1 over 3x minus 6. So again here, I'm just calling my function g. X is my domain variable. So I want to find the x's that I can put into 1 over 3x minus 6 that make that value a real number. Okay? And so here, the first thing to notice is, just like before, I can rewrite this function. And so now it's a little easier to see that if x is equal to 2, I get something that's undefined, or not a real number. So here, my domain is going to be the set of all x, such that x does not equal 2. Any other value that I plug in there, I can see will give me a real number out. For example, if I put in 1, I can see I'll get 1 over negative 3, which is just negative 1/3. If I put in a positive number like 5, I can put in 5 and I'll get 1/9. And so any other number I put in there will give me something real. So that's the only part that's not in my domain. For this next one, h of t equaling the 4th root of t plus 9. Now notice here the variables changed a little bit. I'm not looking at f of x. I'm now looking at h of t. Some of your functions are going to have different domain variables. So remember, h is the name of my function, t is my domain variable, and here's what my function is being described as. Now looking at this, I've got a 4th root of a t plus 9. 4th roots, I know that anything I put in the root has to be positive, otherwise that root becomes undefined. So here we can see if I put in a negative 9, I'm going to get 0. If I put in anything less than negative 9, I get something undefined. So for this one, we can see that my domain is going to be the set of all t, such that t has to be greater than or equal to negative 9. And again, we can check that. If I put in values bigger than that, so for example, if I put in 7, I can get the square root of 16, which will give me, or sorry, the 4th root of 16, which just gives me 2. If I try values that are not in this range, so something like negative 10, I see I get the 4th root of negative 1, which is undefined. Okay. And then this last example, m of y equaling y squared plus 2. Again, variables have changed. Now my domain variable is y. And here, one of the things to notice is I'm squaring and adding. Those are the only operations in there. So unlike the roots and the rational expressions, I don't have any restrictions on y. So that means I can put anything I want in for y, square it, and add 2. So here, my domain is going to be the set of all y such that y is a real number. Okay. Doesn't matter what real number I pick, whether it's a fraction, a decimal, or anything else. I know that when I plug it in there, I will come out with something that works. So in talking about what a function is, there are 4 different representations of functions that we are going to be looking at. And as we define these different representations, keep these in mind as you work through problems throughout the rest of this course. Because again, this is a pre-calculus course, meaning everything we do is going to prepare us for calculus. So the different representations that we're going to see, the first is the verbal description. Okay. And that just means I'm going to describe a function in words. Okay. So for example, a function that takes twice the square of the difference between a number and 1. Okay. Now, for some people who are very auditory, they can read this or hear this, and they're able to determine what the graph looks like or what the function looks like. And again, this isn't the only description that we have, but this is one of the 4 representations. This is probably what you would see most likely when you're trying to solve word problems. We give you a word problem, and you're going to transform that into a different version of a function. One of those other versions would be the algebraic representation. And the algebraic description is just like what it sounds like. I'm going to get an algebraic expression that's going to describe this function. So if I'm going to take a function, I'm going to call it f of x. Again, the name and the domain variable are dependent on what you decide or what the function describes. Some of them will have specifics in there. But there's my function name, and it's going to take twice the square of the difference. So I'm going to need a difference in there, and I'm going to square it between a number and 1. Okay, so there's my function in its algebraic representation. 2 times the quantity x minus 1 squared. Okay. The third representation goes along with the fourth. The third is the numerical representation. And this representation kind of goes back to what we said over here. I'm going to be finding all of the ordered pairs from the domain and range set that'll make up the function. Now, in general, I can't do that for all of them, right? Most of my domains are infinite intervals, and so it's very hard to find every single ordered pair. But the numeric representation gives me a description of these. So it's going to be pulling some subset of the domain and using that to represent my function. Okay? So here in my numeric representation, I can do an x and an f of x, and I'm just going to come up with a table that gives me some of the values that come up for this function. So for example, I'm just going to pick a few of them. Okay, so there's some different x values, and now I'm just going to plug those into my function to get the corresponding f of x value. So at -3, I can see I'm going to get a -4 squared, which is 16, times 2. so that'll be at 32. At negative 2, I'm getting a negative 3 squared, which is 9, so that's going to give me an 18. At negative 1, I get a negative 2 squared, which is 4, so that's going to be 8. At 0, negative 1 squared, which is 1, so that'll be 2. At 1, the whole thing goes to 0. At 2, I'm back at 1, so I'll get a value of 2. And at 3, again, I have 9. Sorry, at 3, I'm going to get a 4, which gives me an 8. Okay, so there's a numeric representation. There are my ordered pairs. Negative 3, 32, negative 2, 18, negative 1, 8, etc. Okay. And then the final representation that we'll see is the graphical representation. Okay. And that is just what it sounds like. I'm going to get a graph of this information, which is going to describe these two functions, or this function. Okay. Now again, in my graphical representation, I can't graph it for everything. I'm just going to use a small subset. Again, for these, you're going to want to label your graphs. Okay, so there's my x, those are my y's, or f of x's. Going by 2's in the y direction and 1 in the x direction. And so I'm going to start here at negative 2. It's going to be a point 18. At negative 1, I'm going to be up here at 8. At 0, I'm at 2. At 1, I'm at 0. At 2, back at 2. And 3, I'm up here again at 8. And so for my graphical representation, I can see that there's a sketch of what it's going to look like. Okay? So those are the 4 different representations. And again, you're going to be asked to look at all of these as we go through this course for various functions, not just polynomial ones.